let's see what we can do. We know this is all going to be E2, yeah. Okay, small strong base. Really the one that do the work is ETO minus equals to RO minus. I see some people was asking why is this one unhindered? Because you only have two hindered, or anything that is smaller than the two hindered, which is on our first page. Okay, anything that's smaller than this two is going to treat as unhindered. Okay, on the table. Specifically here on the table, you will not see ETO minus, you are going to see RO minus. It works the same. Okay. Okay, our ETO minus is going to do the work and it's going to grab a hydrogen. So I do have let me do, okay, here. This is a secondary. I jumped one step, which is how we determine as E2, but it's pretty straightforward on the table, right? Okay. Now, it's going to, and also it's going to form more substituted. So I will still write, okay, Zaitsev. So it means more substituted alkene if we do have. And since it's going to be the E2, and we want to follow antiparallel, the problem is, do I have an antiparallel hydrogen? Okay, is my blue hydrogen the antiparallel hydrogen to my iodide? No. So I should make decision between my yellow, blue, and a pink hydrogen. Okay. If people want, okay, which there also a dash green hydrogen. Okay, let's draw all of them. Yes. You're not expected to draw all of them. I draw them because I think it will be good practice. Yes. Okay. Okay. Let me make a few chairs. Okay. In case I don't need it. Okay. My iodide is pointing up. My green hydrogen. By the way, what's the bond on my iodide? What kind of bond? Axial, right? Okay, green hydrogen is equatorial. Okay, didn't people want to practice with this? Okay. My blue hydrogen, my dash acyl, my red hydrogen, and my yellow. Are we all good with this? Mm-hmm. Okay. Question?
Why is yellow equatorial?
Why is yellow equatorial? Okay. Keep in mind, each carbon can only have one axial and one equatorial. If one of the bond is pointing down, and the other one has, which is axial, the other has to be equatorial. In this position, the equatorial is always parallel to the carbon, the bond is not, right? Okay, yes. Make sense?
Yes.
Okay. So where is my anti-parallel? I think I haven't used purple. I'm saving the purple for now. Here. Are we all good with this? Okay. So how the mechanism works is going to grab the hydrogen and form a double bond. Okay. So I will not write the mechanism because we are doing the product. Okay. But you should know your acyl can stay. Let me just do it with purple. Yes. Okay, this is going to be the only correct product. Okay.
If you had picked a different hydrogen, like the wrong hydrogen, how would it look different, like in the end?
Okay, how would they, if you pick the wrong one, the double bond looks like it will form here. But it's wrong, right? Okay. I can write the wrong one, but I want people to know the difference. Oh no, almost. Okay. This one, right? Okay. But this is wrong. Because you don't have the anti-parallel. With me?
I have a question.
Yeah.
So when you say the more substituted alkene,
Yes, yes.
How does that go into play in this question?
Why are you here? Okay. Okay, how's that going to play? We have no choice yet. Okay, this is not anti-parallel, so
Okay, so we can't even choose.
we cannot even choose. When you get the choice, you can choose between more subject, but here we don't.
So that rule is more like for the linear, or
Yeah, that rules will come here.
okay.
Okay, you have one. All right. Okay. We spent too much time on it, but I just really want people to see if you do have. Okay, the second one is what if you do have. Okay, I'm lazy, so I'll just write my iodide here. Now you do have a anti-parallel hydrogen, which is the light blue one. Then you can do this. Okay. Okay. Okay, and then why I have the third one here. Oh yes, question.
Would that ethyl group be the line, or would it still be the?
Okay, keep in mind sp2 for double bond trigonoplanar. You should not have wedge dash in this case. Okay. I'll repeat this sentence again. It's sp2 for double bond, right? Trigonoplanar. You should not have wedge dash. Okay, who else also have trigonoplanar? Carbocation. Okay. Okay, everything we did has a limitation within the ring. Did people remember? Okay, my number 3 means what if you don't have the ring? My number 3 looks almost exactly the same as my number 1. The only difference is I remove the ring. It's no longer there. Okay, my question is, now my light blue, my light blue wedge hydrogen, okay, my dash green hydrogen, my yellow wedge hydrogen. It's a little ugly, but my little pink hydrogen. Okay. Do I have the problem with anti-hydrogen anymore? No, because single bond can always do free rotation. Yes, okay. You can do free rotation as much as you want. Do I have my problem of my number 1 that my blue does not work? No, my blue work now, because you can always rotate it. How to rotate? Newman projection. Okay. Okay, once you have, then whoever asked me earlier, didn't you say it's all going to be decisive? I choose the same condition. Then whoever is going to be more substituted is going to be the major product. With me?
Mm-hmm.
Okay, now we can do, let's do the counting, which is how many carbon do I have? 1, 2, 3, 4, 5, 6. Okay, well, first draw 6 carbon. Okay, and on carbon number 4, I have a acyl. Okay, 1, 1, 2, 3, 4, 5, 6. On carbon number 4, I have an SO, which is not part of the game. It's just, it wasn't being affected yet. Okay, my blue hydrogen used to be here, right? This is used to be my blue hydrogen. My number 3 used to have an iodide, which is where my, I'm going to color code it with, okay, purple, where my double bond is going to bond from. And my number 2 has my yellow hydrogen. And my red hydrogen, right? I can free rotate to whatever angle I want, as long as it's not. Okay, now I'm going to duplicate this. Okay, this one more. Okay, if I'm remove the hydrogen that is in 3, 4. No. Okay. Or I'm removing one of those. Okay, it really doesn't matter now because I just. Okay, whoever asked we didn't do the Zaitsev, it's based on we have anti-parallel. Now, the one with more substituted is going to be the major. The one with less substituted, the other way, okay? Okay, this is going to be the major, and this is going to be the minor. Make sense? Okay? Okay, in the exam, you are only expected to write the major because the question says draw major organic. If you draw both, you will need to let me know which one is major. Okay?
And so we can rewrite the entire structure like that and let it be all completely like planar and it's fine.
Yeah. Because if you are in a ring, you cannot do that. As long as you are out of the ring, you can do free rotation. Yes.
Will writing the minor structures be an extra credit opportunity?
Oh, okay. Well, we're going to see how people do on this. I'm curious to see. Okay.
Too much work.
Too much work. See, the people say it's too much work.
Major organic compound.
Yeah, we only ask for major to save everyone's efforts and time. If you want to write minor, if S1 and U1, you're going to have a dozen. Okay.
Going above and beyond, though, I feel like does warrant extra credit, and that would be going above and beyond.
Okay, I'll take that into consideration. Might be a good one for 118 people, but for 8, knowing all major will be good enough. Okay, yeah. Okay, my future 118 people will thank your suggestions.